of uh, the development of a master plan related to university sustainability, right? Under my supervisor, all right, which also a very important person in sustainability center of Unimas. Okay, so in relation to my research, I'm doing hydrogen basically. Okay, and I will not disclose the confidentiality of my research, just in general, right? Uh, the waste to energy, all right? The background of the study basically related to waste to energy to produce hydrogen from organic wastewater, like leachate from the landfill. Okay, so I already in my second year of my PhD study and my master program previously as a in master by research. Okay, so I already published several articles related to hydrogen, which is the I can say that the topic is relevant and aligned with sustainability effort. Okay, to ensure that the research can be commercialized in the future, okay, hopefully, in order to meet the SDG, okay, Sustainable Development Goals, all right, in order to make sure that Sarawak, right, can become a hydrogen hub in the future, as being announced by our state minister, Abanjo, all right, related to hydrogen. Okay, so without wasting time, I will share my screen. First, continue. Where is the screen? Oh, fast. Loud. All right. Can you see the? Can you see my slide?
Yes, okay, can.
All right. So, okay. So thank you. Before that, I would like to thanks to RXA for inviting me as a speaker for today's webinar session. Okay, and I responsible to share my insight related to hydrogen and sustainability, right? With the subtitle "Powering the Future Clean Energy Transition." And this topic actually have the relation with several SDG. SDG 7, affordable and clean energy. In SDG 9, industry, innovation and infrastructure. SDG 11, sustainable cities and communities. SDG 12, responsible consumption and production. SDG 13, climate action. And also SDG 17, partnership for the goals. Okay. So uh, in the end of this webinar, okay, the audience uh, will understand these four elements, I hope. Okay. For the first of this webinar session, I will introduce you the hydrogen as a clean energy carrier with three questions. What is hydrogen? Why hydrogen matters and why hydrogen is critical. And the second part of this webinar session, I will provide you my prior knowledge related to hydrogen role in sustainability and decarbonization with a specific uh, description of the rainbow of hydrogen and also hydrogen technology. The third part of this webinar session, you will expect to explore the opportunities and challenges in the scope of Sarawak, Malaysia and Southeast Asia, and also the green hydrogen in terms of its cost, infrastructure and safety concern. And last part of this webinar session, I will share with you by introducing Malaysia hydrogen strategy based on these two components, Sarawak hydrogen export projects and also hydrogen demand and supply, particularly in Malaysia. Okay, so these are the first part of the webinar. Before we go in depth, the hydrogen energy, of course, we need to understand the fundamental of hydrogen itself, right? I believe that everyone have at least uh, know that hydrogen, okay, since our secondary school, we already explored a bit of hydrogen in science, at least science syllabus, or maybe for those who are taking uh, science stream class in chemistry, right, about the hydrogen. So these are the periodic table of the chemical, okay, and hydrogen is at the very top right, left, okay. So as you can see, the hydrogen atom, the molecular weight is 1 gram per mole, which means that I can say hydrogen is the lightest element in the earth, right? And also, hydrogen characteristic is colorless, odorless, and non-toxic gas, all right? And also, okay, hydrogen does not exist as hydrogen atom, okay? And in the earth, it exists as hydrogen gas. Combining two hydrogen atom become hydrogen gas or H2, okay? And the properties of the hydrogen, it has the highly combustible, okay? Highly combustible mean it has a very excellent energy carrier, which I will explain after this, okay? And in relation to SDG, okay, it's in it associated with affordable and clean energy and also climate action. So that's mean colorless, odorless, and non-toxic gas does not harmful the environment. Okay, the hydrogen. All right. So the next will be about the energy carrier. So why does it can be said as exceptional energy carrier? Okay. So first of all, uh, not I hope that you are not confused with the hydrogen. Okay, it's not the source of energy. Okay, what does it mean? Okay, hydrogen is not the energy source. Okay, it's carrying the energy. Okay, it's a platform to transfer the energy. All right. So in terms of the energy carrier, okay, hydrogen offer about 2.5 to 2.9 in range times the calorific value in comparison to the conventional fuel or hydrocarbon fuel like petrol, diesel, okay? And as in the table, you can refer, okay, the list of the fuel types, hydrogen, petrol, diesel, ethanol, propane, wood, coal, and also natural gas. This table has been reported in the literature, so I refer to this table to show to you that in comparison to petrol, hydrogen offer about 2.5 to 2.9 times the calorific value. So it's a very excellent energy carrier, not only capability in make sure that it has what you call that to have a very efficient transferring the energy, but also harmless to the environment. Okay, because hydrogen does not consider as greenhouse gas. Okay, and it's aligned with the climate action. All right. So the third part, the why hydrogen matters. Okay, so as all we know that the if you see the chemical reaction of hydrogen combustion, okay, so the hydrogen gas when it's react with the oxygen, and this oxygen from air, okay, surrounding, when it's react, it will not only generate the energy but also the harmless byproduct, which is water. Okay, so this mechanism reaction usually we know in automobile, like in fuel cell car. Okay, it only generate water instead of GHG or greenhouse gas. Okay, and it does not pollute the air quality. Okay, and also does not emit any greenhouse gas like carbon dioxide. So that's why we can say that hydrogen combustion subject to net zero tailpipe carbon emission. Okay, it produces energy, heat, and water byproduct. So this table showing that hydrogen has been reported near to none producing CO2 emission. Okay, kilogram carbon CO2 per kilogram fuel in comparison to gasoline. Okay, this gasoline I forgot to replace with petrol. The same thing, yeah. Gasoline usually used in US and our country like Malaysia, we use petrol, okay, and also with diesel, ethanol, propane, wood, coal, and natural gas. Okay, so in 2050, okay, the hydrogen uh, development, okay, the roadmap actually align with the Paris Agreement, okay, for the climate action to combat the climate changes, because hydrogen combustion doesn't emit any GHG. So we are hoping that this hydrogen development, the hydrogen technology development, can achieve a zero emission of CO2 near to 2050. Okay, all right. The next will be why hydrogen is critical. So this one is for this slide. Hydrogen actually a sustainable energy solution. Okay, why it considered as sustainable? Because hydrogen support near zero greenhouse gas, as I already mentioned in the previous slide, near zero greenhouse gas emission. So making hydrogen as an attractive clean fuel for decarbonizing effort in the industrial sector, especially that emit abundant of greenhouse gas, right? Including transportation, like in automobile, industry, and power generation. Okay, so these are the flow chart of the role of hydrogen in several industry. Okay, so hydrogen can be utilized in the power stationary or power grid to supply electricity, and also hydrogen can be synthesized from the oil and gas activity from the natural gas. Okay, so this natural gas to hydrogen can be considered as blue hydrogen, okay, because it's involved carbon capture storage, because natural gas is non-renewable resource. So that's mean nat non-renewable resource mean this pathway of hydrogen does not consider as green hydrogen. Okay, it's under blue hydrogen type. And if you realize natural gas, the arrow towards the top, okay, these ones we still rely with conventional method in the moment at the meantime. Okay, like what I can relate this, we in Kuching, uh, in Sejingkap power plant, okay, we still rely with coal as the fuel to supply electricity within Kuching area. Okay, so we hope that in the future, okay, when the core resource is depleted, okay, we have already a matured technology to generate hydrogen so that this hydrogen can be used as the main resource or the fuel to supply electricity. Okay. And this hydrogen also are not only used within our local region, but it also can be export to overseas, okay, through a careful transportation and storage, okay. And this the what you call this, the heavy vehicle here, the symbolize CO2, okay, from the conventional pathway just now through the synthesis of natural gas, because we are trying to ensure that this energy sector, okay, does not emit any CO2, okay. And also the electricity, when we use hydrogen, it can be said the energy is clean, okay, which can be used in the transportation like fuel cell electric vehicle, in residential, and also in the heavy industry. Okay. All right. So the next one will be, why does the hydrogen can be said complements renewable? Okay. As what I said in the previous slide before about the hydrogen as energy carrier, okay, we can see here we can see clearly the role of hydrogen, okay, as energy carrier. So we are not only rely with only hydrogen, okay, combustion to generate energy in transportation, okay, in power stationary, but we also actually rely with several options of renewable energy like solar, okay, hydro power, and also wind energy. Okay, so like in Malaysia, we have solar and hydropower in Sarawak. Okay, so in in the case where our Malaysia in Sarawak particularly, when the day is too sunny or too windy, okay, it will generate excessive amount of energy input. Instead of we waste this energy, right? Because to generate this energy also quite cost consuming, right? Instead, we just waste this energy, okay? We will store this energy, okay, temporarily in the form of hydrogen, okay? I already mentioned hydrogen is not the source of energy, but it's a energy carrier. So this hydrogen, the role store the energy in the form of hydrogen, okay? So how we actually transform this from excessive energy input to hydrogen form is through water electrolysis. Okay, I think in Sarawak we already have the hydrogen generation and refueling station in Kuching for hydrogen bus. So the same mechanism where we split the hydrogen and oxygen molecule from the water. Okay, water into hydrogen and oxygen through water splitting process. So this oxygen will just emit to the surrounding. Oxygen also not a greenhouse gas. Okay, harmless to the environment. And this hydrogen we will store. Okay, in the hydrogen tank. Okay, so that's why I can explain about the surplus generation. Okay, and the second will be the large scale storage. So for the storage stage, the hydrogen will be compressed, liquefied, and sometime and some application it will be converted to ammonia. Okay, or injected into dedicated salt caverns and depleted gas field. So dedicated salt caverns and depleted gas field, basically, for now, Malaysia is still not applying this approach. Okay, we only uh, compress, liquefy, or convert to ammonia approach. Okay, for the large scale storage of hydrogen. Okay, because hydrogen is combustible, highly combustible, so it's need to be carefully stored. That's why the hydrogen, when we try to export it to outside from Malaysia, we need to convert it to ammonia. So a further explanation of this will be in the next slide. Okay, so where TWH scale energy density are possible at cost below pump hydro or lithium ion for multi-day storage. So we want to ensure that this hydrogen can be stored at a very long time without causing any uh, depleting of hydrogen amount, and also for the safety concern. Okay. Okay, the next one will be the reconversion and sector coupling. Okay, so this one basically when at that time there is no wind or solar output, okay, very low amount of wind and solar energy, then this hydrogen that we store, okay, will be utilized, okay, as the alternative, okay, to ensure that the energy can be sustained, the electricity supply can be sustained. That's why we need to have, that's why hydrogen is very important in ensuring a sustainable of of energy. Okay, so here the hydrogen that we store will be undergoes some process. Okay, by feed to the hydrogen turbines or industrial boiler, so that this hydrogen become the fuel to generate electricity and also heat, okay, to the grid, and also supply transport fuel, building heat, and industrial feedstock. Okay, so hydrogen does not only use as um, you know, for industrial usage, but also it become a fuel to supply electricity. So the same mechanism like in the existing power plant, like in Kuching. Actually, I have experience work in intern, okay, in Senjika Power Corporation in Kuching. They are using boiler, okay, to generate steam, and this steam um, will be a what? Uh, there are some kinetic energy mechanism in order to supply electricity to the power grid. So the same concept for hydrogen, but only different here is the fuel. Instead of we use coal, currently in one day we will using hydrogen as the fuel, which is clean and doesn't harm the environment quality. Okay, all right. The next one will be the rainbow of hydrogen. So there are several classification of production pathway. Okay, so the one widely known in actually in my research, from my research point of view, is the gray, still widely applied in industry, in energy sector, gray, because we still have abundant amount of natural gas, and somehow this subject to carbon dioxide emission. Okay, we cannot rely with gray hydrogen and for a long time. Okay, because natural gas is not renewable. Okay, if you see the gray hydrogen, so it's undergo reforming process to generate hydrogen, but it still emits CO2 significantly. So in energy industry currently, they have the effort to combat the CO2 emission by introducing blue hydrogen pathway. So this blue path hydrogen, they're introducing the carbon capture storage, okay, to ensure that this CO2 will not emit to the surrounding, okay, and this CO2 can be used for other purpose, okay. Still the same resource, which is natural gas, but it's capture the CO2 to generate hydrogen. And still, this resource for the blue hydrogen is non-renewable. But currently, these are the most practical pathway to produce hydrogen at the moment, because we cannot rely with the green hydrogen. Okay, green hydrogen still sacrifice to produce the desired amount same as gray hydrogen, okay, production rate. That's why we still need blue hydrogen at the moment and gray hydrogen. So for the green hydrogen, the input is renewable like biomass, solar, and also wind energy. Okay, wave energy as well. So this energy input will be utilized uh, by the electrolysis platform like water splitting just now. Okay, and it will generate hydrogen and oxygen. Okay, but there is no carbon dioxide emission. Okay, does not harm to the environment. So for the yellow, pink, turquoise, and brown, okay, a bit rare actually. If you have a reading about this, or you have like prior knowledge of hydrogen pathway, they only address the green, blue, and gray, but we have other different color of hydrogen type: yellow, pink, turquoise, and brown. Okay, for the yellow, the difference with the green is only the source of the energy from the solar or grid. Okay, so what does it mean by this grid? Basically, the coal, okay, the coal that used as the fuel, okay, produce electricity, okay, will be used for electrolysis. Okay, electrolysis is renewable. It's a clean process, but the input is not clean. Okay, not clean mean it produce GHG byproduct, greenhouse gas byproduct. Okay, so that's why it's categorized under yellow hydrogen. Okay, for the pink hydrogen, our country we are not using nuclear, so we might not familiar with this type of process. Okay, but the source is from nuclear. Okay, the source of energy is from nuclear and will be used for water splitting, okay, to generate hydrogen. And the turquoise, okay, turquoise hydrogen, we use non-renewable resource like natural gas or methane, and then This methane will be undergoes pyrolysis process to produce hydrogen and also carbon, not carbon dioxide. It's a carbon. It's a solid uh, deposit. Okay, it's a solid formation carbon, which is also not a renewable pathway to produce hydrogen. Okay, because the primary resource of energy is natural gas and the byproduct is carbon. Okay, but this carbon usually will use for other purposes as well. Okay, okay, not just what not it's a it should be a useful product. Okay, and last but not least, the brown hydrogen, okay, from the coal or biomass. But the reaction here, they are using gasification. Okay, so the coal will be burned and it will gasify the CO2 and hydrogen. And still, it's subject to CO2 emission. Okay, so one day, okay, we hope that we can reach the level where the hydrogen production fully rely with green hydrogen pathway. Okay, so now is the hydrogen technology a key enabler of the clean energy transition? So this subtitle describes several components, okay, in the perspective of energy storage and grid stabilization. So I already uh, share with you about the this one, Prima Renewable. Okay, it's the same explanation for this particular uh, energy storage and grid stabilization. So we want to make sure that the electricity supply is consistent without fluctuation. Okay, so now we not experiencing any fluctuating of electricity supply due to we are still relying with non-renewable resource like coal, right, or natural gas. In Bintulu power plant, they are using natural gas, if I'm not mistaken. Okay, in Kuching, we are using coal to generate electricity. Okay, so here we want to ensure that when we use renewable energy one day, like power, like solar energy, wind energy, we want to ensure that the consistency or the stability of the power grid. That's why hydrogen is very, very important to ensure that this can be realized, okay, by store the excess energy input as the electricity backup, okay, so that we can enhance the grid reliability. Okay, so I already give some, like I draw some circle there, okay, with to address at which region in this figure that I telling about. Okay, so hydrogen storage will be supplied to the grid service when we when the condition, okay, the other renewable source like wind energy and solar energy is at a very low level. Okay, so the next one will be hydrogen turbines for power generation. Okay, so this one I already shared to you just now also about the hydrogen turbines. Okay, so the hydrogen turbines for power generation. So these are the mechanism that occur within the power plant. Okay, before this electricity is generated and supplied to the power grid. Okay, network. So this hydrogen turbine doesn't nearly at nearly at zero CO2 emission. Okay, and also complement renewable energy source. So this also related to the previous slide, okay, involving hydrogen turbines. And the next one is the transportation. We want to ensure that the future vehicles, okay, with zero emission feature, okay, and covering for a long range and heavy duty transport, okay, like fuel cell electric vehicles, ships and plane, okay. One day we hope that we can reach this milestone, where we can reach the maturity in terms of clean transportation in Malaysia. But I consider the fuel cell electric vehicle, okay, the hybrid car, they are using battery, right? Which is, to me, not renewable enough. But from what I heard, uh, they are selling separately the battery and the car in order to make sure that uh, we can minimize the environmental impact due to the battery of the for every car unit. So I think that's one of the effort, okay, in the industry to combat this environmental impact due to the battery for the hybrid car, which not only use fuel cell but also integrated with battery for electricity. Okay. All right. The next one is the heavy industry. So this heavy industry involves several sectors like ammonia synthesis for agriculture, where this ammonia can be used for fertilizer production. Okay. And because we convert hydrogen to ammonia, I think I already mentioned in the previous slide, ammonia can be used for agriculture activity, and hydrogen also can assist the production of cleaner fuel, okay, for the oil and gas sector in the steam reformation and cracking. So for this oil and gas sector, I'm not limiting only green hydrogen, but also other type of hydrogen just now, like blue hydrogen. Okay, blue hydrogen, it's capture the carbon, okay, carbon capture. Okay, so the last one is the steel production. Okay, it's reduce iron ore without CO2 emission. So here I want to ensure that any process um, can achieve zero emission of CO2. Okay, by application by widely applying hydrogen as the energy supply or electricity supply to the factory. Okay. All right. So the next slide is about the opportunity for Sarawak, Malaysia, and Southeast Asia. So here I showing you the figure of our Earth. Okay. And Malaysia actually placed at the near to the equator. Okay. So we are receiving sunlight 12 hour per day every year for over the year, right? So this climate, okay, is a very have the benefit to us, okay, our country, including Sarawak, okay. Due to this strategic geography, it uh, lead to the abundance renewables energy, okay, including hydrogen. From because hydrogen not only synthesized, I mean the hydrogen is not only synthesized from uh, the what you call that, organic carbon, because we cannot simply get hydrogen directly like that. Okay, it should be synthesized by undergo some process like fermentation, okay, or water splitting just now, so that we can get hydrogen, pure hydrogen. So with the sun ray 12 hour a day in Malaysia, we can have sufficient, or technically we can say consistent amount of energy input from solar, okay, especially. And this can lead to the industrial decarbonization and green job in Malaysia. And so we hope that it help our society, in terms of employment, right? Green jobs especially in the energy sector. Okay. So this Sarawak map showing the point of the hydrogen hub. Hopefully one day, in Kuching, Bintulu, Samalaju, and Miri, the power plant. We hope that we can realize the uh, the significant application of hydrogen in the power plant, instead of we relying with the non-renewable resource like natural gas and also coal. Okay, so everything have its pros and cons. However, the way we view the constraint, okay, we can find the opportunity to resolve the constraint. So these are the first challenges, okay, which involve the innovation, SDG 9, SDG 7, clean energy, and SDG 17, partnership for the goals, okay, which involve collaboration project. Okay, so here we can see the figure of production costs, the comparison between green and blue hydrogen. Okay, so in 2021 compared to 2030, okay, 2021 the cost of producing green hydrogen is significant compared to blue hydrogen. That's the main reason why the current energy sector still relying with blue hydrogen, even though the resource is not renewable, but it's a mixed energy strategy, because we cannot rely 100% to green hydrogen at the moment, because of the cost to produce green hydrogen is quite expensive. All right, based on this report. So their expectation, okay, green hydrogen will undergo cost reduction in the future, at least in 2030. Okay, we want to ensure that green hydrogen is cheaper compared to blue hydrogen in 2030. And hopefully it's the production cost is near to the zero, not to the zero. Of course, it has a market value, but at least more cheaper than blue hydrogen, when we can see the gap, all right, in 2050. So we try to achieve affordable hydrogen in the future in 2050. So how we can realize this cost reduction? Through innovation. So the collaboration project like UKM, University Kebangsaan Malaysia, and Petronas, uh, the research in the hydrogen production via water electrolysis, where their research is highlighting to reduce the production costs, where their research is about the solid oxide electrolysis cell. Okay, the solid oxide is quite expensive at the moment. So their research is to ensure that this material the cost can be reduced. Okay, and also they have other initiative, the bipolar plate design and membrane electrode assemblies, so that we can have a cheaper than the current price of the fuel cell, okay, to produce hydrogen. And another achievement in Sarawak, okay, related to hydrogen production via water electrolysis. Okay, now we have a hydrogen plant, not is a hydrogen what this a water splitting, okay, water splitting process to generate hydrogen, and at the same time it has the refueling station for the hydrogen bus, which I believe this is the first time of integrated hydrogen production and refueling plant that developed in Southeast Asia. So Sarawak is the first one that realized this. Okay. And these are the second challenges regarding the infrastructure gaps. Okay. So as you can see the graph, the curve uh, at the innovation stage, okay, we can see the it's significantly rapidly reach the peak, but at some time at when times goes by, it's undergo depletion, right? So why this happened? Because of the infrastructure gaps. So it's slowing the progress of hydrogen development. So here it's very important to have a very good government efforts in the through the policy incentive. So I provide you three policy incentive. The first one is the green investment strategy. Okay. So green investment strategy involving two roadmap, which is the new industrial master plan 2030 and national energy transition roadmap. Okay, so from these two documents, they're highlighting the 7 key low carbon areas, which include hydrogen, okay, biohydrogen, and from this green investment strategy, the government hoping that they can attract at least near to 8 times amount of investment to Malaysia. So this green investment strategy, not only for the local, but also for the foreigner. Okay. And also another purpose is another target is to leverage foreign direct investment in green technology sector and improve green investment ecosystem. Okay. In order to overcome these infrastructure gaps, okay, with the active investment from outside of Malaysia. Okay, and the next one is the green technology tax incentive, which are here split into three. The green investment tax allowance, GITA. Okay, GITA can be split into asset and projects. Okay, the asset is applicable for companies that acquire qualifying green technology asset and listed under My Hijau directory. And for the project kita applicable for the company that undertake qualifying green technology project for business or own consumption. Okay. Another tax incentive, which is GITE, which is applicable for qualifying green technology service provider company that are listed under the My Hijau directory. Okay. So last but not least, I think this one is the widely known. Okay. In my reading, we always heard about the hydrogen economy and technology roadmap. Okay. And from this document, I addressed in 2023 that highlighting the infrastructure gaps. Okay, Malaysia officially recognized its hydrogen infrastructure shortfall lack of production hubs, storage facility, refueling network, and grid adapted pipeline. Okay, all right. So these are the another challenges regarding the safety concern, which involve a global collaboration between Sarawak and Japan and also Korea. Okay, to date. Okay, for the meat ammonia. And for methyl to export hydrogen in the form of liquid to Japan, okay, for energy consumption, and also hydrogen Hornbill project, H2 production from hydropower, because hydropower, we have the hydropower, right? So we try to take this advantage to ensure that the stability of hydrogen production. Okay, and what are the safety concern that highlighted here is the high pressure hydrogen handling risk, lack of safety, infrastructure at scale, variable feedstock condition, complicate design, and also disjoint safety standard. So this global collaboration will ensure that this safety concern can be resolved in the future. And for your further reading, these are for your information. Sarawak Hydrogen Export Project also involving hibiscus or hydrogen viscous project. Okay, for the green ammonia. Okay, to convert hydrogen into ammonia for the temporary storage, and the Petronas Kentari, okay, to centralize the Sarawak as the hydrogen production hub. Okay, all right. So we are actually approaching a, a very end of this webinar, basically. Hydrogen demand and supply Malaysia. So here we have the figure that showing the demand in Malaysia, hydrogen demand in several sectors like transport, steel, other industry, and ammonia and methanol production. So here we can see that the hydrogen demand is we can see significantly rising. Okay, but Malaysia currently, okay, we still the production still not uh cannot afford with the demand of hydrogen at the moment. And based on the hydrogen economy and technology roadmap, Malaysia try targeting in 2030 2 million ton per year. As what I said, they cannot rely with green hydrogen, but also with blue hydrogen through introducing carbon capture storage. And in 2050, we hope that we can reach production of hydrogen of 16 million ton per year, which reflecting a long-term shift towards 100% green hydrogen. Okay, by comparing with the global data, it's a 6 gigaton annual. 16. Sorry, here is I don't see 80% of final energy demand, which indicate about 60. Okay, 60 gigaton per year of the hydrogen production. Okay, all right. So the conclusion of this webinar and the main takeaway, hydrogen is a driving the global shift toward clean, renewable energy as a versatile and sustainable energy carrier. And it offers a key solution for reducing emission and enhancing energy security, supporting a low carbon future. And Sarawak, particularly, is positioning itself as a regional leader in green hydrogen production and export. Last but not least, realizing hydrogen fuel potential require innovation, infrastructure development, and strong collaboration. So I end my webinar with this phrase: the energy of the future began with understanding hydrogen today. So thank you for your listening. Okay, that's all from
Thank you
me.
so much. All right, thank you so much for the presentation. Thank you and for all the information that has been shared. So we'll now proceed with a short Q&A question. So if the audience have any questions, please feel free to type it into the chat. But just to kickstart, perhaps I have a question here. So how can local entrepreneurs or business in Sarawak get involved in the hydrogen industry or participate in hydrogen related projects?
Okay, all right. So now I present to you this part. Okay, our government role is very important to ensure that the small entrepreneur and also the business related to energy sector can achieve their vision and mission, okay, their respective vision and mission through the policy incentive. All right. So one of it is a green investment strategy. Okay, with this policy implementation, um, we can encourage the foreigner direct investment. Okay, so that we can driving what you call that, to ensure that the facility can be improved from time to time in order to achieve the hydrogen roadmap. Okay, and also the green technology tax incentive. Okay, locally for the company that supply and consume the green hydrogen. Okay, the incentive. Okay, the exemption of the tax. All right, and also the role of the policy itself. All right, that can ensure that the entrepreneur and also the small local business can contribute to the significant development of hydrogen. Okay, I hope that I'm answering your question.
Okay, all right, yeah, no worries. Okay, so I do have another question here. So, because the production of hydrogen can be complex and requires high pressure, hydrogen fuel can
Mhm,
be costly. So, furthermore, for transportation to use hydrogen fuel requires different mechanics, which can also be expensive lah. So, how to ensure
mhm.
a transition from petrol to hydrogen fuel usage among a large population?
Okay, all right. So I can relate with the project, the global collaboration project between the INEOS, Sumitomo Corporation, and SEDC Sarawak. They due to the safety concern, because of the high pressure. Okay, so methyl cyclohexane is the process after we convert hydrogen to methyl cyclohexane in order to export this hydrogen from Sarawak to Japan. They convert into methyl cyclohexane before they ship to Japan in the form of liquid formation lah, for to minimize the storage and also transport hazard. Since we know that hydrogen is very uh, is a highly combustible gas, so we need uh, to convert this hydrogen gas to other form for the temporary storage or for transporting the hydrogen. Instead of we transport the hydrogen directly, during when we ship to the Japan, for example, in this context. And another project that can relate with the safety concern just now is the high to viscous project. They convert this green hydrogen into ammonia, okay, for transporting the hydrogen into Korea, all right, in the form of ammonia in this case. Yeah. I hope that I'm answering your question.
Yep, yep. Okay, all right, great, good to know. Okay, so I think there are no further questions from the chat box today,
Mm-hmm.
and so I
All
think
right.
maybe we can have a quick group photo